Morning, everyone. How's everyone doing today? Feeling pretty good after Bash last night? Yeah. The Powerades are great. There's a little tip there. So welcome again to day 2 of This is the Build and Deploy track. My name is Kelvin Yap. I'm the MC. First up today, we have a really awesome talk by Lachlan Daly from Atlassian. If you were just in the keynote and you listened to both Scott and Didier talk about all things teams and DevOps, this is a really good follow-on presentation. Good on you guys for being here. I'm going to get off stage. And so without further ado, please welcome Lachlan Daly.
Hi everyone, my name's Lachlan Daly. I'm with the build engineering team at Atlassian. I've been with Atlassian for about 3.5 years. And today we're going to look at a bit more of a practical deep dive on some of the content that was covered in the keynote. Has anyone ever heard of a game called Factorio? A couple, cool. I personally love Factorio. So much so that I had to ban myself from playing this game. And the reason I mention it is because it's a surprisingly good example of many of the techniques that are used in DevOps to enable scaling. To explain the game, it's sort of like Minecraft. You know, you mine resources. And then you automate the mining of those resources. And then you automate the construction of the tools that you use to mine those resources. And then you automate the construction of the factories that make the tools that you use to mine those resources. I personally knew I was in too deep with this when I had to spin up a Jira instance to track the work that I was doing. And to me, Factorio is an incredible illustration of the power of automation and the insane scaling that automation allows you to achieve. It's this power of automation that is the key driving force of DevOps. However, both automation and, in turn, reaching a certain level of scaling presents some real challenges. Today, we're going to look at how we've used automation to achieve the scale we currently have. And then I'll work through how we've dealt with some of the challenges that operating at that scale has brought. We'll see what happens when you bring together the right mix of people into an environment where they can achieve massive automation, and how this in turn can be used to spread a DevOps culture throughout the organization. So this is the agenda for today. We're going to look at automation first. Automation allows you to focus on a core value proposition of your team by automating out the annoying, repetitive, boring bits. Then we'll have a look at ChatOps, and ChatOps tracking and support, which all support automation. ChatOps helps you scale by eliminating wasted time searching for information. Then we'll cover tracking, which allows you to focus on the places where changes that you make will have the biggest impact on your service. And then we'll have a look at support, and we'll discuss how adding a few generalists to your team can solve problems a lot faster than a team of specialists, allowing those specialists to really dive in and focus on their speciality. But first, let's have a quick look at what my team, Build Engineering, actually do. So Build Engineering. Build Engineering's mandate is to build and maintain the platform required by Atlassian's developers to build, test, and release their products. So our customers are internal Atlassian developers. We're essentially an operations team that was able to scale by stealing the best practices from development teams. And then we were able to scale further by stealing the best practices from support teams. That last guy is me a couple months ago, and I had a sweet mustache. So what numbers are we talking about when we're talking about scaling? In the past 2 years, we've seen a 1.8 times the growth in our number of customers, those being the internal Atlassian developers. And over that time, how much has our team grown? We've actually had 2 people lead to other teams in Atlassian. So we're servicing 1.8 times the number of customers with 2 less people. So, automation, how do we do it? For us, everything starts with automation. We've realized that to truly scale, you need to automate every facet of your work. Why? Because automation allows you to focus on the stuff you actually want to get done. But of course, you really need to be deploying that new release. And you have to configure those servers that you said you would. But before you can even do that, you have to install that new infrastructure. Well, automate installing new infrastructure. Automate configuring your servers, automate deploying a new release, and focus on the stuff you actually want to get done. So, for illustration purposes, let's meet a new startup. We'll call them Fried Fritter. And Fried Fritter has a massive new release that they've been working on for months. They've tested it thoroughly, but come deploy day, let's see what happens. One of the regions goes up in smoke. So where there's smoke, there's fire, and the solution to fighting fires every release is a continuous integration and continuous deployment tool. Continuous integration and continuous deployment involve a ton of repetitive tasks, which humans are really bad at and they're bound to screw up. Using a tool that does this for you eliminates the risk of human error when testing and deploying your software and saves you time because you don't have to constantly perform these risky releases manually. A strong continuous integration tool helps you construct a pipeline for your project in which you can build, test, and deploy your software. A side effect of automation is that it hides things. So although you have this wonderful stream of content coming out from your pipeline, if you don't have a continuous integration and continuous deployment tool, you lose visibility into what's actually occurring. So bringing visibility to your automation is very important. For us, we use Bamboo internally, as well as Bitbucket pipelines. This screenshot, of course, is of Bamboo. It helps us track what's running on our environments. In this screenshot, although we can see there are some different build results used, so 1727, 1724, they're all green, and they're all well-tested versions of our software. So going back to our startup, Fried Fritter, it turns out that on that final third environment, someone had deployed the wrong release, which contained a massive bug. A continuous integration and continuous delivery tool would have helped them avoid this. It also helps them break down their releases into smaller chunks, because they would have been constantly testing their code. They'd know when it was possible to release. For me, there's no better feeling than a long string of green ticks in my life. It's the best. So, Fried Fritter has successfully implemented continuous integration for their product. And they built a really nice pipeline in which things are running much more smoothly. However, they're gaining popularity. And what was once 3 servers to deploy to is now 20 servers. These servers each use the JRE to run their application, and a new security patch has just been released. Updating the JRE across these 20 servers would be a ton of manual, repetitive, tedious work, which again, humans are really bad at. Inevitably, someone screws it up. Surely there must be a better way of getting this done. There is, and its configuration as code. So, configuration as code allows you to steal from the way software teams build their products for the purpose of maintaining infrastructure. And this is the first big step towards scalability for any DevOps team. Configuration as code allows teams to reclaim the time they're spending doing manual configuration and invest it back into growing their service. It also introduces one of my favorite concepts, pets versus cattle, coined by Bill Baker from Microsoft. The gist of this is that you name pets, and if a pet gets sick, you take it to the vet and you spend time and money nursing it back to health. Cattle, on the other hand, you give numbers, and if they get sick, you shoot them, and that's that. You get a new one. Pets versus cattle and configuration as code means that you're eliminating configuration drift, because you're treating all your cattle, all your servers in exactly the same way. You spray them with the same pesticides. And of course, it gets you faster deploys, because no longer are you SSHing into each server individually to install the new JRE, for example. It all happens in one place. The benefits of configuration as code really can't be understated. So what does it look like in practice? For us, we use Puppet in the build engineering team, but of course you can use Ansible or Chef, whatever you like. In this example, we have a file called clean_m2local, which sits in the Puppet repository. And we want this file to run once a day, so we put it in the cron daily directory. And we need it to have certain permissions, so 755 and owned by root, group root. And what does this look like? This looks like this. So across every single server that we've connected our Puppet master to, they all get exactly the same configuration for this file. So a server configuration tool like Puppet is great, but Fried Fritter made their real breakthrough when they realized that they could take everything that they'd learnt from continuous integration building their software and apply it to their server configuration. So they built a new pipeline for their server configuration. And all the benefits they were seeing with their CI tool, they're now seeing when they're building and deploying their configuration on their servers. These benefits include stuff like rollback, and as Scott mentioned in the keynote, collaboration. So you get pull requests, code reviews on configuration changes, and disaster recovery. You can go back to any version which is in your Puppet repository. So, Fried Fritter has their server configuration sitting in a repository, being code reviewed, and deployed via a continuous integration tool. But once again, a new release goes out to production and something blows up. They realized that one of the files that they had configured in their Puppet repository had incorrect permissions and couldn't be accessed by their application. And it was missed in code review. If only they could test their server configuration before it hit production. Well, luckily for Fried Fritter, you can and you must test your server configuration, as a configuration management tool is only as strong as the test that it runs. So the two important techniques in testing server configuration are virtualization and behavioral testing. So what does the testing process for server configuration actually look like? It's essentially 3 steps. 1, spin up an instance. 2, apply your configuration management and deploy your app to that instance. And then 3, run your tests. So for us, the 2 tools that we use for virtualization and behavioral testing are Vagrant and Cucumber. So we use Vagrant to spin up instances of specific configurations using AWS. It then integrates with Puppet to install your server configuration onto that instance. And it's super useful for getting started with automated testing of server configuration. In this screenshot, I've got a Bamboo server running in a Vagrant image, ready to go, which is a very, very close mirror of our production Bamboo servers. From there, we use Cucumber, our testing framework, which integrates on top of Vagrant and automatically runs a suite of tests after the instance is provisioned. They're executed on the server and they verify its behavior. So in this example, we've got a Bamboo agent, and a Bamboo agent has to have specific capabilities, otherwise it's not a Bamboo agent. And we have a bunch of scenarios that inform what a Bamboo agent is. So for example, a Bamboo agent has to have a home directory. So we have a scenario that makes sure that there is an environment variable which is the home directory. They're super quick to write and they're very easy to understand. So, Fried Fritter has a wonderfully tested server configuration which is mass deployed out to all their servers, and their continuous integration system is helping them nail their deploys. Life is good, but with their growing popularity, they realized that the machines that they had put together to handle the load just aren't beefy enough to cut it. They need to rip out all their hardware and replace it with newer machines. But that might take months and would be a massive upfront capital cost to their organization. Luckily for them, they came across the concept of infrastructure as code just in time. So, infrastructure as code means that you can treat your hardware as code, which gives you access to all the techniques for agile software development, but applied to building and deploying hardware. So Fried Fritter sold all their old hardware and migrated to the cloud so they could take advantage of infrastructure as code. So for example, having migrated to the cloud, they have a Jira server. And this Jira server, which they use internally to track their work, is getting really slow. And it's getting slow because it just doesn't have enough CPU available. So let's see how infrastructure as code can help them solve this problem in a single line, a single change. So this is Fried Fritter's Jira server as described by an infrastructure as code tool called Terraform, which we use. But CloudFormation templates get you the same thing. In the same way that we can configure our servers with Puppet, we are able to build hardware with Terraform. So for example, if they wanted to increase the amount of CPU on their Jira instance, it's a one-line change from M4 2x large in instance type to M4 4x large. And this is sent straight to AWS, and it looks a little like that. So it's just that easy. So going back to our startup, they realized that since Terraform does basically the same job with with hardware that Puppet does with software, they could again take everything that they learnt from continuous integration with Puppet and do it again with Terraform. So they built a pipeline for their hardware configuration. And all the benefits that they gained with CI, with the CI tool that they were seeing when building their software, they're now seeing building their hardware. So we're talking about stuff like rollback, collaboration, and no elimination of snowflakes for hardware. It's a massive step forward. So to recap, we've seen the importance of continuous integration via Bamboo, and how it can help you avoid making mistakes and fighting fires every time you need to cut a release. Then we looked at how configuring a fleet of servers is no longer a mind-numbing chore, but just a matter of writing some code in Puppet. Then we looked at how testing this configuration is possible, thanks to Vagrant virtualization and behavioral testing via Cucumber. And finally, infrastructure as code via Terraform gives us hardware as code. So for Fried Fritter, everything is automated. And this means that they can focus on the stuff that they actually want to get done. And all this content, I've used a startup as an example, but this is exactly what we're doing in the build engineering team at Atlassian. So that was automation. Let's look at some of the ways that this automation is supported by other things that we do within our team. Firstly, let's look at ChatOps and how building a command center will help your team scale. So the definition of ChatOps, as said by Sean Regan, is software and IT teams evolved from email to chat. They also replaced repetitive tasks with automation and replaced annual change control meetings with DevOps continuous collaboration. And then they pulled it all together in a central tool like HipChat. And to me, the most important part of this is pulling it all together in a central tool. I like to think of HipChat as the command center of my team. It's the first thing that I check in the morning, and it's the last thing that I check before I leave at the end of the day. For almost everyone in our team, HipChat actually sits on a separate monitor 24/7, and that's all that monitor does, shows HipChat. It also gives you a high-level overview of what's happening if you're on your mobile. So while you can't necessarily fix the problem, you can get in contact with someone who can, or you can give them advice. And the massive benefit of building this command center is that you will spend no more wasted time searching for information. It's all in one place. So in practice, how do we use HipChat? Well, the build engineering team has 4 main rooms. We have the public room, and because we provide a service, we have customers, and we need to interact with those customers. And our favorite way of doing that is via HipChat. We also have the private room, where we discuss the work that we're doing that day and collaborate on getting pull requests merged. We then have the alerts room, and the alerts room is where we send all the alerts from our various servers into one place. And lastly, the Fight channel. And the Fight channel is our direct link with the Bamboo team, who are one of our upstream dependencies, who we're very, very reliant on. So having a direct link of communication to them, we found has been a massive improvement for our team. So, how can we use ChatOps successfully? Well, one of the things we realized is that there's actually it's quite painful to get a pull request merged if you think about it. First, you need to have approvals. For our team, every PR needs at least 2 approvals. Then you have to get green builds, and that could be 1 green build, that could be 10 green builds, who knows, it really depends on your setup. And then you have to make sure you have no open tasks, and checking all those things is very time consuming. So we decided that instead of making people go off to various places, we would just pull all that information into HipChat, and we would have a shared pool of pull requests. So our team doesn't actually use assignees for pull requests. We have one shared pool, and the only way that works is because we have a tool which makes all those pull requests visible to our users. So in this case, we have a sidebar glance. We call it the OpenPRS bot. And it shows that in this case, I have a pull request which has got 10 green builds, so that's good to go. It's just waiting for approvals. So all I need to do is ping a couple guys in my team, maybe just post a general message in the HipChat channel being like, hey, is there anyone who has a couple spare cycles available to review this for me? It means you have less time chasing pull requests and more time building and scaling your service. So you're a DevOps team, you're running a service, and you put together a really, really comprehensive knowledge base, so good on you. But no one knows where it lives. And it's super hard to find things in it because it's really technical. And people aren't searching. They're searching with the questions they're asking, not the titles of your pages. We found that this is a massive problem for us, and we were able to mitigate it somewhat by making another HipChat bot we call the AskBot. And what the AskBot does is it is a simple !ask trigger and whatever you're searching for, and that will go off to our knowledge base in Confluence questions and our Confluence space and pull in what it thinks is the correct answer. So in this example, Rich is asking how we can SSH into one of our agents, our machines. Thomas knows this is quite a commonly asked question, so he replies with SSH, ask SSH build agent, and boom, the exact answer that he needs right there, and Rich is good to go. This saves Thomas a hassle of going off to try and find the right answer, and it also trains your users, because this is in our public room, which is visible to everyone, and they know that we have this knowledge base, which they can go and search. So, alerts. Alerts are fantastic until they start to overwhelm you. Alternatively, if you ignore them, they're completely worthless. So our solution for alerts and the problems they cause was sending them to HipChat, where they're visible, but not in your face. We also found that inline chat was extremely powerful when dealing with alerts because it allows these alerts to be discussed inline and dealt with by the right person as they occur. So in this case, Colin finds that the tardigrade Bamboo server that we supply had a Puppet run fail, and it's like, well, what's going on with that? Chandler replies saying, oh, maybe it's this problem. And then, a minute later, Brad comes in saying, hey, it's actually this thing that I'm already working on. So that's instantly someone who knows exactly what's going on and no waste of time for Colin and Chandler trying to chase up what's happening. So I heard you like bots. So I put bots in your bots so you can scale while they bot. And the way we did this is with NannyBot. It's a tool that we built for rapid bot development. Often building a HipChat bot, you don't really want anything too fancy, but the framework that you use can give you whatever you want. So we wanted a really quick way of making quite simple bots. So in this example, we've got a webhook which looks for hello, hi, bye, or see ya. And if it detects hello or hi, it responds with hi there. If it detects bye or see ya, it responds with bye-bye. In practice, we use this for integrating with our microservices. So we have a bunch of little tools which expose APIs, and then we build the HipChat integration for those things in NannyBot. Makes really, really fast HipChat bot development. So now time for a quick story. I think that one of the most underrated parts of ChatOps is building an environment in where people feel comfortable. DevOps is a cultural thing, and there's no more powerful cultural force than a communications tool. And ChatOps is about getting the best out of a communications tool. And getting the best out of a communication tool requires that people feel comfortable using it. So my first time working in the BuildEng team, I was really, really fascinated by how openly people were talking to one another. And I thought to myself, why is this? And I realized it was because people were comfortable using the tool. In my previous team, we had one HipChat room, which was a global room, and there was something like, 50 people in it at all times. And that made people feel like they were speaking in front of an audience. And people get quite uncomfortable when they're speaking in front of an audience. So by building a private room, we found that, and with about 10 people or so in it, which was just the core team that people interact with every day, they were much more comfortable using the tool, which led them to investing in the tool and making all these chatbots that I've demonstrated today. So your ChatOps changes will save you time, as all the information you need to get your job done will be available in one command center. You'll see your DevOps culture spreading to other teams throughout the company, because many of those ChatOps tools that you make are public-facing, and for every cool improvement you make, other teams are going to want to steal that. So that was ChatOps. Let's have a look at tracking and how you can build an army of sentinels to keep an eye on your services for you. So the big point that we have learned about tracking is that everything you seek to improve, you must track. So tracking gives you the ability to refine the most problematic areas of your platform and even fix things before they become a problem in the first place, helping you make the most of your limited resources. By tracking both your system and your users, you can rely on actual data to decide what needs fixing. Try and track this data manually, however, would be both a massive time sink and highly error-prone, so your tracking must be automated. So in this case, if you have 3 competing bugs, how do you know which one to address? I mean, surely they're all going to hurt people, but what is actually going to hurt people the most? Without tracking, you'd have no idea. But let's have a look at a typical incident. Yep, that definitely looks like an incident to me. Incidents and performance issues suck. Figuring out what resource the servers run out of is usually pretty straightforward, but mapping what the system is actually doing to that resource limitation is quite hard. So we found that by collecting as much information about our services as we could and then sticking them all in one place, we were drastically reducing the amount of time required to resolve incidents with our platform. So by investing in not only tracking the server resources, but also key load indicators, so in this case, how many agents are running on a Bamboo server, for example, we can predict and then alert on incoming outages and address them before they bring the service down. So in this case, we know that when agents spike on Bamboo, that's often when a problem is going to occur. So we have alerting that triggers when that agent summary reaches a certain point. And then we can quickly, once we see the alert, we can go into Datadog, which is our monitoring tool, and have a look at what the system resources are actually doing. And if that high amount of agents is actually causing load limitations. We also paired that up with wallboards, which give us the most important details about a running instance. So in this case, we have Confluence Cloud Bamboo, one of our Bamboo servers, and it's got 409 active agents on it, which is a lot of load. That's a very busy server, which might be cause for concern. But we can also see there's only 11 queued builds. So instead of being a super busy server which is about to crash, it's actually just running really well. So most of the time, your deployments will succeed, and that's great. But sometimes they won't, and that's a sad thing. Which is why it's really important to send deployment notifications to HipChat, where a failed deployment can be discussed and actioned in line immediately. Or in this case, a successful deployment can be celebrated. So you have a ton of alerts probably, maybe a forest of alerts, but do you know which ones are actually useful? Perhaps the alerts have become irrelevant over time, or maybe they're unactionable, or perhaps just the thresholds are wrong. Alerts are only useful to you if they aren't spam. And the fix to this is tracking your alerts. So we use Datadog, and Datadog gives us a breakdown of what alerts we're actually seeing the most in a certain week. So in this case, we found that the disconnected agents check had sent us 418 alerts in the last week, which was crazy. That's a huge amount of time that our team needs to spend just making sure that this alert is actually useful. So we investigated it, and we found that this alert was coming from one server which was just completely broken. So we fixed that up from the server, and it disappeared. And that was a ton of work that our team no longer had to do, so we could go back to building what we were working on in the first place. Another massive thing that you should do with your alerting and your monitoring is break down the barriers that exist between your tracking and your customers. This is a form of automation, and it's a form of automation because it empowers users to check the status of the servers for themselves. So we built this tool called Service Desk Bamboo, which is like before we acquired Statuspage.io, so we'll be migrating in the future. But essentially, it does the same thing with a couple more exposure of our core stats of a server. So for example, on a Bamboo server, response time is really important to a user. And the build queue size is really important to a user, and agent status is really important to a user. And this means that our users can diagnose performance problems with our Bamboo servers themselves, rather than just guessing if it's a local problem for them. So if you track your service, shouldn't you also track how people use your service? In the build engineering team, we definitely think so, and we do that with the contact rate. Contact rate is the concept of how often your users are contacting you. And what it is it's the amount of contacts you receive in a certain period divided by the amount of people who use your service. And so, for example, the amount of people using our service is the devs in Atlassian who contact build engineering. In the past 2 years, it hovered around 50 to 60%. So 1 in 2 developers was contacting our service. And over the past year or so, via making a bunch of improvements to the way our services run, we've been able to reduce that to about 35%. So how do we actually count that contact rate? We built a tool called BECA, which stands for the Build Engineering Contact Rate. And what that does is it uses a fairly naive algorithm to go through all of the HipChat contacts that we receive. And if there hasn't been a contact in the previous 10 minutes, and it's from someone outside our team, then it's automatically classified as a contact. We then go through those contacts and classify them into particular categories, so we can know what part of our service is causing the most pain. So to show how we've used that in the past, one of the most painful areas in our service for our customers was Maven usage. So not only does the build engineering team provide Bamboo servers, we also provide the Maven infrastructure that the Atlassian developers use. And we found that we were getting tons of questions around how to actually use Maven. And we realized that we needed to do something about this. So we built a tool called MASH. And MASH stands for the Maven Atlassian Self-Help Tool. What it does is it provides a layer. So the Maven tool we were using was a third-party tool, and we couldn't change this. So what we did was we built an abstract layer on top of it, which provides the most important information that we thought was relevant to our users in a really easily searchable place. And by doing this, we were able to eliminate a huge chunk of the contacts that we were getting from that Maven usage category. It's no longer even in the top 5. So one of the goals of DevOps is to break down the boundaries between teams. Originally, this is just between dev teams creating the products and the op teams who are running the products. But I believe this should extend to your customers as well. Giving your customers access to your tracking not only helps build a culture of openness and trust, which is so critical for DevOps, but it's another form of automation, as a user checking your service requires no work from your team itself. So that was tracking, but where does support fit into all of this? Well, support protects your project work from being interrupted, allowing it to be completed faster. And to me, I believe it's the next phase of DevOps, bringing support into the mix. However, traditional support is backwards. Support best practice requires you to be proactive rather than reactive. Thus, DevOps teams need to integrate support best practice the same way they've integrated dev best practice. Let's have a look at how this works in build engineering. So we have 3 sub-teams in build engineering. We have the dev sub-team, the operations sub-team, and we also have a support sub-team. And the support sub-team are called the Shields. And there's 2 of us, me and a guy still in Sydney. We also add a maintenance rotation from the dev and the ops sub-teams. So once every 5 weeks or so, you'll join the Shields to work on issues that are raised by customers. So it's a rotation. And this is sort of how it flows. We have 3 main vectors of how our customers communicate with us. We have HipChat, where most of our contacts come from, Confluence Questions, where some of our contacts come from, and Service Desk, where the remainder of our contacts come from. And these are all handled by the Shields. The Shields own those communications channels. They'll handle as many of those as they can. But if there's a project which is going to require sitting down and taking a lot of time to do, or a very specific knowledge of a certain aspect of our platform, it'll be handed to the people who are on maintenance. And if those maintenance guys realize that it's too large a project for them to handle on their rotation, or if it requires even more specialized knowledge, it'll then get passed on to either the dev sub-team or the operations sub-team. On that previous slide, you saw there were 3 ways that Shields can be contacted. And honestly, that's already too many to expect your users to remember. So our solution for that was building what we called the supportal. So the reason we built this is to minimize points of contact and reduce the burden of knowledge that is on your users when trying to interact with you. Big companies are going to have a ton of different services that operate internally. So making yours as easy to contact as possible is really important. So what the build engineering supportal does is it provides all of the information that we think a customer needs in one place. So one URL they have to remember. It has service status, it has recent issues, it has our knowledge base. Most importantly, it has our change log and how you can raise an issue or search our knowledge base, which autocompletes, so it's super useful. It also has links to all our training material and our blog posts, which we use to communicate all of our major changes to our customers. So, unfortunately, our services are quite complicated, and they can be really hard to use. And also, people have really diverse use cases. And what we realized was that our small team, trying to support everyone using these services just couldn't possibly scale. And we needed to proactively build experts outside of our team who can onboard newbies on their team onto how to use our platform. And we did that in 3 main ways. The first is with boot camps. We really love boot camps. We find they give new starters a massive jump up on the learning curve. So we have 2 major boot camps that we run monthly. We also have user groups where we give presentations not unlike this one to other teams in Atlassian about upcoming changes with our platform or best practices that we've learned. And lastly, our public forum. So our public HipChat room usually has maybe 100 people lurking in it on a daily basis. And whenever we're answering questions about our platform, all those people are seeing those answers and just osmosifying the knowledge. But it's not enough to just do that. And we found that it was super important to get even more proactive because it's super easy for teams to dig themselves into a hole when using our services. And we wanted to steer them on the happy path. So instead of taking a machete and hacking through the jungle, we wanted them to walk down our nicely curated garden path. And we did that with a project we called Pipeline Consulting. So we found that a lot of teams had very convoluted pipelines, which are hard to work with. So we built a survey of about 30 or so questions, which aimed at finding out what makes your pipeline hard to work with. In this example, we're looking at retry attempts. So if you don't have retry attempts in your pipeline, you might have builds which are going forever, and you never know if they're green or red, they're just nothing. So it really slows down the dev loop for a lot of teams. From these questions, we ranked them on which ones we thought were the most important, and then we scored them on a score from 0 to 5 for each one. And from that score, we looked at the ones which were the most important for teams to fix. So in this case, the person who took the survey got 86% on their pipeline, which is a pretty solid pipeline. But if they address those 4 things which are highlighted right there, it would jump over 90, which is an excellent pipeline. So it gives the teams the biggest bang for their buck when they're looking to fix pipelines. But we didn't stop there, because it's not enough to just tell people, like as Scott mentioned, it's not enough to just diagnose problems. You also have to direct teams on how to fix it. So we built essentially what's the same as the playbooks. We call them plunger guides. Long story. But it essentially gives examples of how to get started with fixing and making the changes needed to get a perfect score in these categories. So to me, the next phase of DevOps is bringing extra focus to your customers via proactive support. And it protects your project work, allowing your new features, to get rolled out faster with less interruptions. So I discussed a lot of tooling in this talk, so just to do a quick recap, our team relies heavily on the Bamboo stack. We have Bamboo for continuous integration, HipChat for ChatOps, Bitbucket for our repositories, Confluence and Confluence Questions for our knowledge base, and Jira Service Desk for our issue tracking and customer interactions. But we also love using third-party tools as well, particularly ones that integrate well with our products. We use Puppet for configuration as code, Terraform for infrastructure as code, Vagrant for virtualization, Cucumber for behavioral testing, and Datadog for tracking, monitoring, and alerting. But we recognize that teams do come in all shapes and sizes, and this is just works for us. This is just what works for us. Each team has their own preferences, and one of the things that I think is really cool about the Atlassian stack is there are a ton of different integrations with other tooling that will help you scale your DevOps team. So configuration, testing, dependency, analytics, security, deployment, hosting, monitoring, all of those have integrations with our products, which make them super easy to use. So to recap what I talked about today, automation is the heart of DevOps. And automation allows you to do repetitive tasks once and only once, allowing you to spend time growing and scaling your services with the same resources. It's supported by 3 other things. ChatOps, your command center, which helps you spread your DevOps culture to other teams. Tracking, which keeps your automation visible and helps you share your tracking with customers, embracing DevOps' culture of openness and trust. And lastly, support and protecting your project work, and doing so proactively. So in conclusion, DevOps is the cultural shift that occurs when a team embraces automation, allowing them to massively scale their services without the cost of expanding their team. So go download Factorio and give yourself a practice run, and then go back to work and start automating out the boring bits and get back to building the future. Thank you.
Yep, I think I did. Yeah, awesome. Thanks, Lachlan. That was great. Unfortunately, don't have time for Q&A. However, Lachlan is going to be standing at the back if you have any of those questions that you submitted on the app, or if you have any additional questions. But thanks, everyone.